Today we are going to be looking at learning target 5F, describing the correlation of data in a scatterplot. Make sure you set up your Cornell notes so that you have the key points of positive versus negative correlation, strong versus weak correlation, the difference between correlation and causation, and what a lurking variable is. The first thing we want to look at is positive versus negative correlations. A positive correlation is one where as the x value increases, the y value increases. So the data will trend up and to the right. A negative correlation is as the x value increases, the y value decreases. So the data trends down and to the right. And no correlation represents a situation where the data is all scattered and there isn't a clear increase in both variables or increase in one, decrease in the other. It's just a little bit helter-skelter all over the place. So you're looking at either positive, negative, or no correlation. The second thing we want to look at is a strong versus a weak correlation. Now, we help judge this by how tightly our points fit around our line of best fit, which you learned about in learning target 5E. If it is a strong positive or a strong negative, the data fits very tightly around the line of best fit. In the case of a strong positive, the line would be going up and to the right, with the data fitting close to that line. If it's a strong negative, the line would be going down and to the right, and the data would fit very closely. If it's a weak positive, the line would be going up and to the right, and the data would fit loosely around that line. The same thing applies for a weak negative, where the data is not quite as clustered, as tight to the line. No correlation, again, means that you could almost draw a line anywhere, and it would look like a possible line of best fit. One thing to remember when you look at lines of best fit is that they do not always need to start at the origin 0, 0. In the instance of the weak positive correlation here, the place where the line fits the best is for the line to start just slightly above 0, 0, which is just fine. It also could start below 0, 0 as well. Either place is okay, just recognizing that that line is a linear function, so it has a slope and a y-intercept, and we just have it as our best estimate of where a point would be along our line. The third thing we want you to get out of this is correlation versus causation. Correlation means that there is a relationship between two variables. Causation means that a change in one variable causes a change in another. Just because two variables show a correlation does not mean that they show causation. An example of this is that a correlation is that people who own red cars tend to drive faster. Now, that does not imply that owning a red car makes you drive faster. It means that people who have personality traits or have a reason to drive faster tend to own red cars more often. Causation would be that people who drive faster tend to get more speeding tickets. That is a direct cause because driving faster puts you in a situation to get a speeding ticket. There's a direct, definite link between those two. The first one is simply just a relationship between noticing something about people who drive red cars and noticing something about people who drive faster. When we talk about correlation versus causation, we always want to be aware of possible lurking variables. A lurking variable is a variable that could possibly impact a correlation observed between two variables. So the situation that we have is people who use more sunscreen have a lower rate of getting skin cancer. Now, does using more sunscreen lower your chance of getting skin cancer? Not necessarily. There is a relationship there, but not necessarily a cause, because of our possible lurking variable being the amount of time you're in the sun, or the amount of sun exposure that someone has. A person who is never exposed to the sun could never wear sunscreen and would never get skin cancer, whereas someone could be in the sun all the time, use a lot of sunscreen, and still wind up with skin cancer. So that lurking variable, the thing that's really impacting the rate at which someone gets skin cancer, is the amount of time they're in the sun. That is our possible lurking variable. Make sure you guys have these notes down so that you can use them when answering your questions on the project.